So hi guys, so today we'll be discussing the module 4. So I'm going to just share the screen for the same. Time response analysis and stability analysis. Okay. So coming to the time response analysis, we got two systems. One is the first order system and second order system. There will be learning about damped, undamped and all of those conditions. And stability analysis. So the first part, as you can see, this is a very important question which can be asked for the examination. Concept of stability, necessary condition for stability. That's the very important question. And in this also, time response of second order system, we can have a derivation for the underdamped system, as well as we can have numericals on the first order system. So these are the important things. And also for the unit step function also you have to learn. So time domain, correct? So time domain in the sense with respect to time, we will be analyzing the output, okay, of the system. Then one is natural response and forced response. The two response systems are, one is natural, correct? Another is forced. Forced meaning external, by some external media. Then transient response and steady state response. Transient meaning, see, momentary change, which means if I switch on the fan, if I'm switching on the fan, immediately if I see the fan, it will start to rotate, right? Just like that. Correct? Immediate response. That is called transients. Within that second. Correct? It will be very, very fast. So differentiation. di by dt and all of those things. Those things are transient response. And steady state means normal. Natural and forced response. Natural in the sense, see, external forces are set to 0. So there is no outside force involved in it. Correct? So it will have the initial condition with voltages and currents set to 0. Forced response. Forced response in the sense with 0 initial condition, in the sense the external voltage, correct, and the current source with the 0 initial conditions. There is something about the forced response, that is 0 state response. This is 0 input response and that is 0 state. Here the voltages and current are independent, but here the voltages and current are dependent and we'll make it to 0. So that is the only difference. Transient response, I already told you what it is. Correct? Yes. Change in input and all of those things. So just relate to real world objects so that you'll be able to understand. Again, don't get too much involved into this because this won't be asked in the examination. Then this is what I told you. Unit step function, which they can ask. But I'm not going to touch these things because it's not going to come for the exam. Whatever is going to come, that only I'll be taking. See, damping means disturbance. You can see a wave, right? Correct? A full wave. Then also in ECG, can you see a lot of zigzag thing kind of things? A wave in ECG. That is called damped, which means disturbance is there. Disturbance is called damping. Okay. As you can see, this is what I am telling you. This is our normal undamped. No disturbance is there. But you can see here, right? The damping. Okay. So I think the meeting got cut a little bit. Now I'll share it. Yeah. So again, from the diagram only we have to learn, not through by hearting. Let me just cut all of these things and then I'll come back later because what I want to tell you is very, very important. There is stability. Let's see. Then afterwards I'll come here to the numericals or whatever it is. because they can ask this for 6 or 8 mark stability thing. Yes, I think it is. So stability analysis. So as you can see here, stable, neutral, and unstable. Correct. If it is con is kept in this manner, it is what? Stable. Then if I keep this con here, it might fall anytime, right? It's unstable. So we have all seen the flyovers, no? Correct. Some flyovers will break down in the middle. So all of this is due to what? Stability, unstability, or it is unstable in nature. So this should be a stable graph, neutral and unstable. You can see in the, this is what I told. This is a hanging bridge over here, correct? So all of these conditions are applied in real life also, and it has broken down. Anyway, we will see the important question, that is this. Okay, concept of stability and its what are the conditions for stability? Okay, so zero state response means we already discussed in natural and forced was there, right? Previously, correct? So there is a response only due to input only. All other initial conditions are kept to zero. Correct. Then we got Bibo. So no need for you to mug up this thing, bounded input, bounded output. But if it is there, then it's good. For examination, you can write it down these things so that they'll give some extra mark. So input is what? Obviously, the input condition is changed with the system's output condition. That's it. In the sense, input is dependent on the output. So then we got zero input response. Then asymptotic stability. These two are not that important. This one is important, stability criterion in a complex plane. So a system is stable only if all the roots of the system characteristic equation have negative real parts, or all poles of the closed loop transfer function must locate in the left half of the S plane. Okay. So coming to the Bibo stability and asymptotic stability, they have got same requirement on the pole location. So you can see the stability conditions, correct? Location of the poles, all poles in the LHP, simple poles on the JW axis and no poles in the RHF. This is marginally stable, and if it's unstable, everything should be, at least one pole there should be there in the RHF. Marginally stable, simple poles on the JW axis, no poles on the RHF. If it is stable, all poles in the LHP. Okay, so these things you have to remember. P stands for poles. Then this is very, very important while writing the answer. The necessary condition for stability. This has been repeatedly asked in the examination also. So if we can see this polynomial, SQ plus 3 square plus 16S plus 30, correct? So these are all positive, correct? So to root to be in the left half, left S plane, correct? The left hand side plane, LHP or LSP, correct? Left hand plane for stability. All these things should be positive in the sense the coefficient. What is coefficient of SQ? 1. Positive. Coefficient of S square plus 3 positive, plus 16 plus 30. So everything should be positive. Number one thing. Then by using determinants also we can find. So you should write a determinant thing, correct? Delta n, an minus 1. Here it is minus 1, minus 3, minus 5. Then it is minus 2, minus 4, minus 1, minus 3. 0 here. Just subtract 1 from this, an 0. This is a naught, that is my 0. Then delta 1, if I am putting, correct, should be greater than 0. Delta 2 should be greater than 0. Delta 3 should be greater than 0. All of those things, if it is condition satisfied, then this system is said to be stable. So these are the important conditions. Then Routh stability criteria. That you need, that's a separate question altogether. So all poles in the left S plane, no poles in the right S plane. Correct. then what it is, without actually calculating the root, in the sense all poles in the left S plane, LSP, no poles in the right S plane. Right S plane means, again you should write either mildly stable or not at all stable if it is in the right S plane. Same sign it should have. If it is all the coefficient should be negative, everything should be negative. If everything is positive, then that is positive. So that's it. So that's it, guys. This is the important things. And in one more session, I'll be explaining you regarding the top part. That is the derivation part.